All right, let's crack the code on Module 6, where we're tackling correlation and regression. In this quick guide, we're going to give you a super clear framework so you can confidently answer any exam question on this topic. So let's just dive right in.
Okay, picture this. You're in the exam, the clock's ticking away, and you land on a question with two variables. That little bit of panic starts to creep in, right? Is this correlation? Is it regression? What's the difference again? That exact moment is what we're preparing for right now.
So here's our game plan. Think of it as a diagnostic funnel to get you to the right answer fast. First, we'll nail that crucial decision. Are we describing something or are we predicting something? Then we're going to learn how to spot the hidden traps examiners love to set. I'll give you the ultimate golden rule to live by, and we'll wrap it all up with a rapid-fire checklist to make sure it all sticks.
Okay, let's get into it. The very first and honestly, the most important question you have to ask yourself when you read a problem is, what is this question really asking me to do? This slide is basically your secret decoder ring. If you see words like relationship, association, strength, or direction, your brain needs to immediately scream correlation. But if the question uses words like predict, forecast, estimate, or it's asking for an equation, then you know you're in the world of regression. This is your #1 filter.
So when you're describing that relationship, your go-to tool is the correlation coefficient. We just call it R. Think of R like a simple scorecard for the relationship. It's just one single number, somewhere between -1 and +1, that tells you two super important things. How strong is that linear relationship, and which way is it going?
And for predicting, your tool is the regression equation. You can think of it as your own personal statistical crystal ball. You just plug in a value for X, and boom, it spits out a prediction for Y. Just remember this key difference. Correlation describes, regression predicts.
Now, just knowing the difference between the two isn't quite enough. You see, examiners absolutely love to set these little statistical traps to see if you really get the context. So let's look at how to spot them.
There are two major traps you really got to look out for: lurking variables and the infamous Simpson's paradox. Let's break them down so you can see them coming a mile away.
First up, the lurking variable. The best way to think about this is like a hidden puppet master. It's some third variable that you're not even measuring, but it's secretly pulling the strings on the two variables you are looking at. It makes them seem connected when they might not be at all.
Here is the classic example, and it will lock this concept in your memory forever. So, ice cream sales go up, and at the same time, drowning incidents go up. So, does eating ice cream cause drowning? No way, of course not. The lurking variable here is hot weather. The heat causes people to buy more ice cream, and it causes them to go swimming more. So you always have to ask yourself, could something else be causing this pattern?
Okay, next up is Simpson's paradox, which I like to call the ultimate statistical plot twist. Seriously, this is what happens when you see a clear trend in a few separate groups of data, but that trend completely vanishes, or even reverses, when you lump all those groups together. It's a classic trap, and it usually involves percentages in groups of different sizes.
Okay, let's look at this data really carefully. In program A, De Anza has a better success rate, right? 60% beats 50%. And in program B, De Anza also has a better success rate. 80% beats 70%. So if you look at each program by itself, De Anza looks like the clear winner. But the paradox happens when we look at the overall numbers. The reason this is such a trap is that the group sizes are totally different. See how De Anza has most of its students in that high success program, while Foothill has most of its students in the lower success one? This unequal weighting completely distorts the big picture, and in a lot of cases, it makes the overall trend flip on its head. That's why you have to be suspicious whenever you see aggregated data.
All of these traps, all these pitfalls, they all lead us to the single most important rule in this entire module. This is the one thing you absolutely cannot forget when you're interpreting your results.
Association does not imply causation. Seriously, say it again. Burn this phrase into your brain. I promise you, it will save you so many points on your exam.
All this means is that just because two things are correlated, it doesn't mean one is causing the other. Our ice cream and drowning example is perfect proof of this. So, unless the data you're looking at comes from a properly controlled experiment, you can only say there's an association. You can never claim there's a cause and effect relationship. Okay, time to put it all together. Here is your rapid-fire checklist to run through during the exam. This is exactly how you'll diagnose any question they can possibly throw at you.
First up, if the question asks you to predict, or forecast, or estimate, your immediate thought should be regression.
Next, if the question is asking about the relationship strength or the direction of a trend, that is your signal for correlation.
Okay, what if the data shows one trend in the little subgroups, but a different, maybe even opposite, trend when you look at the total? You need to be on high alert for Simpson's paradox.
And if you read a scenario and you can think of some plausible third thing that might be causing both variables to move together, you should absolutely suspect a lurking variable is at play.
And finally, the golden rule. If two variables are clearly moving together, but the data is just observational, it's not from a controlled experiment, you cannot claim causation. Period. End of story.
Just run through that checklist every single time you see one of these problems, and I guarantee you'll be able to figure out exactly what to do. You've got this. Good luck.